Exercise 4B, question number 1. Um, an accountant monitors the number of items produced per month by a company together with the total production. There is a table. You can see that the number of items N and the production cost P, and draw a scatter diagram to represent this data. So yeah, so I did a sketch. So you can do a scatter diagram in a proper graph paper properly, and I will let you do it. And then the equation of the regression line. So the regression line equation given. So we have to draw in the on the line. So I will write 21.0 0.98 n. So I like to write in this way. This is y equal mx plus c form. And how do you draw this line? So you can draw this line by taking 2 points. Assume n equals 0. What is p value? P is 21. So then one coordinate is 0, 21. Then take another one. N equal 1. P equal n equals 0, actually out of range. But you can mark that point, and you can mark the other point somewhere here. It doesn't matter, it is out of range, but you can draw the line in between the range. So n equals 0 you can take easily, and n equal, let's say 100, n equal 100, then p equal 0.98 times 100 plus 21. It means 98 plus 21. That's a good value. It's going to be 919. The other coordinate is going to be n equal 100, n equal 100, and other one is 119. It is a integer value, and you can keep these values, and with a ruler you can draw the line and see. Interpret the meaning of the figure 21. So this is 21 when you extend this one. This is 21, and this is the gradient. Now, what 21? What is 21? 21 means 21,000. So what is the meaning of this one? Is the production cost when uh, number of items is 0. Basically, this is in a company, this is fixed cost. And then what is 0.0.98? So it is the gradient. Gradient means P divided by N. So B divided by N is 0.98. So I can write 1. As a ratio into P. Into B mean 1 to 0.98. If the number of items produced increases by 1, the production cost approximately increases by 0.98. So you can tell this answer in terms of thousands. You can multiply by 1,000 and 1,000. Then this is going to be 1,000 to 980. If the number of items produced by 1,000, then the production cost approximately increases by 980 pounds. Part D, comment the suitability of this. The company expect to produce 74,000 items and 94,000 items. So 74,000 items, 74,000, it means 74 in terms of here somewhere, and 95,000, it means 95 somewhere here. The comment on the suitability of this is going to predict of the production cost each of this month. So basically this 74,000, it's a 74 is a value within the range, within minimum and maximum. Hence this data is a interpolation. Uh, when calculating cost when n equals 74 is a interpolation. Hence hence value is more likely to be reliable. But calculating the cost when n equal 95 is a extrapolation. Hence the value is less likely to be reliable. Question number 2. The relation between a number of coats of a patient applied, coats of paint applied to a board and resulting whether resistance was tested in a laboratory. The data collected. This is number of coats and the number of years. So draw a scatter diagram. So I give a rough sketch of this one. You can do a proper one. The part B, the equation of the regression line. So y equal, I will write the in this form 2.93 y equal mx plus c form. The Helen said that the gradient of 1.5 means if 10 coats of paint are applied, the protection will be it lasts 14.5 years. Comment on the Helen statement. The number part B, because so gradient is 1.45, then MOX 1.45. If it is 10 years, it is going to 14.5. Okay, having this knowledge now, 10 years. So when x equal 10, it is out of range. So calculating number of protection years when n equal 10 is an extrapolation. Hence, value is not value mean the protection value for this number of protection here. Value is not reliable. Instead of hence, you can write more meaningful if you want. Hence, hence number of protection years is not reliable. And the other one, so when it is 14 1.5 times 5x, when n equal 10, y value is 1.45 times 10 by 2.93, which is 17.43, not equal to 14.5. Hence, Helen calculation is wrong as he forgot to include forgot to add the constant 2.93 years when the which is the weather resistance when no paint were applied. When n equal 10, so this is not equal to 14.5. Hence, Helen's calculation is wrong as he forgot to add the constant 2.93 years when which is the weather resistance when no paint were applied. Question number 3. The table show the ages of some chickens and the number of eggs. So the age and the number of eggs, and there are some data. So we want to draw in a scatter diagram. So I just do a sketch. I did a sketch. Now part B. Robin calculate the regression line as n equal 0.063a 16.1. Without further calculation, why the Robbins regression equation is uh, incorrect. So we can tell that when you look at this scatter diagram, so it shows that weak negative correlation. Uh, the diagram shows weak negative correlation. Hence, gradient of the line of best fit is negative, but the gradient 0.063 of the given regression line is positive. Hence, Robbins' regression equation is not correct. The scatter show a weak negative uh, correlation. Hence, the gradient of the line of best fit is negative. It should be negative. It should be negative. But the gradient 0 of the given regression line is positive. Hence, Robin's regression equation is not correct. You can write one more if you want. Hence, this is contradict. And hence, Robin's regression equation is not correct. Question number 4. Aisha collected data on the number of bedrooms X and the values Y, and she given regression line 50x plus 190. She stated the value of the constant in a regression equation mean that a house with no bedroom in a village would worth 190,000. It means when x equals 0, y value is 190, mean 190,000 in terms of thousands. Explain why this is not a reasonable statement. Because we know that it's a house is not a flat, so at least in a house there's at least one bedroom, so hence this is not a reasonable statement. So we can tell that there are unlikely to be any houses with no bedroom. Further, this could be an extrapolation where linear relationship uh, does not exist, because usually when we gather the data, we gather one bedroom, this is the price, two bedroom, this is the price, and again two bedroom, this is the price, three bedroom, this is the price. We don't gather data zero bedroom, this is the price. So this is not practical. Because of that, this could be an explanation. Question number 5. It is about visibility and humidity. humidity as a percentage. This is, and part A. So this is the equation given. Part A, explain the gradient of this regression line. What is the meaning of gradient? Gradient mean it is 1%. The visibility is coming down 406 meter. So if the visibility, uh, the humidity increases by 1%, then the visibility is decreased by 106 decameter. Part B question, it is about the causal relationship between humidity and visibility. So we know that when humidity increase is not directly applied to visibility, because humidity not directly depend on the visibility. What will happen when humidity, because of humidity, the misty or foggy condition increase. So because of that, the visibility is decreasing. Hence, there is likely to be a causal as humidity increases, misty and foggy condition which decreases the visibility. Says visibility. Part C. Give a reason why it would not be reliable to use regression equation to predict one 100% humidity and one is 3000 decimeter visibility. Part C number 1. So we can see in the graph the data set the maximum visibility is 9, humidity is 98. So 100 is the extrapolation. So maximum is 98 and 100 is a extrapolation. So extrapolation is less reliable. Uh, the prediction for 100% is an extrapolation. Hence, prediction may not be reliable. May not reliable. The next part is the humidity on the day with visibility of 3000 decameter. So usually from this regression line we can predict the humidity. When we give a humidity, then we can predict the visibility. But we can't work out the other way around with this equation. When the visibility is given, we can find the humidity. The graph is plotted for uh, visibility given humidity. Hence, it is not possible to predict humidity for a given visibility. Hence, it is not possible to. The graph is plotted for visibility given humidity. Hence, it is not possible to predict humidity for a given visibility. Part D state two ways in which better use could be made of the larger data set to produce model. Describe it. Yeah, this is the data set. Basically, we know that the data set we can improve the accuracy by one is randomness and increase in the sample size. So precision of the model can be increased by obtaining more and more random data and by increasing sample size. So you have to answer this part relevant to under this theme, because we know that the accuracy is increasing when the data is are more randomized, as well as when the sample size is increasing.